Looks like it's a review of the others.
Practice from the previous one.
So that was good because I almost feel like I got it. Like I got the standard deviation. I get that, you know, that calculation. I was like, you know, I watched the videos and they said stop them and see if you can figure it out yourself. And I was like, look at that, I got it. Yay.
Yeah,
that's always nice.
We're getting there.
Always nice. It just clicks, you know. I got 100 on the got 100 on the homework. I was very excited.
You did the lesson 7 homework already?
No, that's still lesson 6. No,
I'm
telling you, I'm behind.
I know. I think I'm a little bit behind too. It's just work schedules.
I'll get it done. I'm working from home tomorrow, so I have a little bit more
very
time.
good.
So
very good.
All right.
Should we dig into the quiz, Aru?
Dig into the material. Certainly don't need to read the first 2 questions. So.
Okay.
So question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score of 1.35 and to the left z-score negative 1.358. So, I have my applet open. So I'm sorry, what's the number?
1.358 on each side, but you know, of course, on the left it's a negative.
Yep.
And I think the key here to make sure we don't get it wrong is round to 3 decimal places.
Yeah. So use the normal and a combined area under the standard normal curve. So that's where I always get confused is what you highlight, right?
So it's going to be to the right of the
red line,
and then to the left of the negative one.
Which is, I got 1.75. I mean,
Yep.
0.175.
Yep, 0.175.
Okay, I got that too, so that's good.
0.175, right?
Yeah.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? So if it's 9, so which of the following will have a smaller standard deviation? The distribution of the sample means the distribution. It's a smaller standard deviation.
So it's going to be.
Is it individual?
No, it's going to be the sample means. That's what I think. I guess I could be wrong.
Well, I'm trying to visualize this in my head. It sounds like the
Why
more.
do you think that, James? I'm sorry, Ed. Can you explain why you think it's that?
Because the sample means are the sample size, right? So if you have 100 samples, that mean is going to be, let's say, 5, right? But then if you have individual observations, those numbers could be all over the place. So if you have 9, if you have the distribution of sample means, it's going to be closer together. That makes sense?
It does make sense.
And I'm thinking that that's about right too. Every time you take a sample, you're noting what the mean is of that sample, then you're tossing it back into the population. Then you're taking another sample, you're checking the mean, then you're tossing it back into the population. So you do that 9 times, and then I believe the shape of the distribution curve gets narrower at the bottom. So the distribution of the sample means gets smaller, as is the question.
Yeah.
The shape stays the same because it's normal.
Right.
But the base of the curve would be smaller. So I think that's what I'm thinking.
Yeah, me too.
So 5, which of the following results implies that the spread decreases as the sample size increases?
Ed, you want to take this one for us?
Okay. You know what? Yeah. Okay. So I believe it is the law of large numbers, based on what I just said. The more numbers we're taking a mean count of, the distribution mean decreases. Right?
I concur.
Yep, me too.
Yeah.
Okay. So 6, use the following information to answer the next 4 questions. Scores on the quantitative portion of GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane scored 160 on the quantitative portion. What is the z-score corresponding to Diane's score? Okay, so the z-score, which again, I've got this one now. I understand how to do this one now. Doesn't mean I have to do it, but
Well, and just to talk this through, it's 160 minus 150.8 over 8.8, right?
yep.
Okay. All right. Make sure I got it set up right.
So I have 0.1363. Nope.
I would. So you'd have 160 minus 150.8, which is what, 9.2 divided by 8.8.
1.045.
That's what I got. Yep.
Me too.
100 inches to 3 decimal points. So that's what we're going to put, 1.045. 045, yeah, because it's 0454.
Yeah.
Okay. Oof. Pressure. What's the probability that a randomly selected student will score above 160 on the quantitative portion? Right, so the probability is...
So the probability, that just, like, in my mind, that just equals the area of the probability applet. So area equals probability in my mind. I don't know if that's correct, but that's how I...
No, that
No,
is correct.
you are correct.
Probability.
Yeah, so what we're going to want to do is take that 1.045 and we're going to put it as the z-score.
Yes.
Yep. And it's above, so you only want the right side
Yeah,
highlighted?
the right side's blue, so I have 0.148 or 0.148.
Right.
Yep.
Okay. I agree.
Well, listen,
I think-
Jane, you just made that easier for me
Good.
instead of having to calculate it. And I know she talked about that, but see, that's the little stuff that I don't remember in my head. So, okay. So a random sample of 5 students was selected to take the GRE. Their scores are, what's the Z-score?
So this. So we have the.
You have to get the mean first.
Well, we have the mean,
we have the mean,
right? So the mean is 150.8, right?
Mm-hmm.
And then this, and then the standard deviation is 8.8.
So do we have to?
Sorry, my notes are awful. So
No,
I have to
no, that's fine.
I have my answer, but I just want to make sure we go through it.
Hey guys, I'm your TA for this class.
Hey, Jenny.
Do you guys
Hi.
have any questions? Hi.
Well, we're just going through the quiz right now.
Okay,
and
which quiz are you? What
We're on
lesson?
question 8.
Lesson 7,
Lesson 8? Okay.
question 8.
Oh, okay.
So it's gonna be.
So I don't. So see, this is
Did I
where I
tell-
get like
did I
I
tell
don't
you
know.
my-
I don't know
Did I
where
tell
the
you my
first
thoughts
step
on number
is.
8?
I'm sorry.
Did I tell you my thoughts on number 8?
Yes,
Please
tell
do.
us.
Now, and this might be completely wrong, and as soon as James thought it was more than that, I was, or different, I was worried. Now, because see, now I got the mean of those scores. My mean was 160, not 159. But apart from that, it seems like if the mean, well, let's see, if the z-score corresponding to the sample mean of these student, what is the z-score corresponding to the sample means of the student scores? If the mean is 0 in the population with like 1 standard deviation on each side, but if the mean is 0 for the population, then the mean would have to be 0 for these 5 students as well. Am I oversimplifying that?
What is the question exactly?
Well, so well, that's my question. Is that what you do? Do you get the mean of the 5 scores and then do the calculation to get the z-score, or do you have to do the z-score from every single score individually?
Can you read me the question for question 8?
Sure.
I'm trying to pull it up right
Yep.
now.
It says a random, and the whole thing is we're using this. It's the mean is 150.8, and the standard deviation is 8.8. And then the question is, there's a random sample of 5 students that took the test, and their scores are 160, 175, 163, 149, and 153. So it's what is the z-score corresponding to the sample mean of the students' scores? So I guess my question is, do we add those 5 up and get the mean of those 5 scores? So now we have 160 is the mean of the 5 students that we're talking about.
I feel like it's the same answer as 6.
Yeah, because it's still 160.
Yeah. And that's what gives me pause about, are they really saying that you do the same exact thing on the random sample of 5 students as what we just did finding the z-score in 6?
Well, and that's my question to you, Jenny. Where do we start with this? Do we start by taking those 5 scores and getting a mean for that to get the z-score? Or do we have to get a z-score for each individual student?
Hold on, let me open the quiz. My laptop is kind of lagging right now. Let me just open it.
Somebody's not happy.
That's my son. I don't know what's going on with him.
Oh, poor thing. He
Hey,
knows we're doing math.
he's a punk, so I don't know what his deal is. So I. 8.
Yeah. Jace, can I use your laptop? My laptop is not working with me. Where is it?
Well, do you want me to just share my screen so you can see the question?
Yeah, that would be better. I'm probably going to switch laptops too so I can. Thanks.
So I have an answer, but I gotta figure out where I got it from. I got
Can you-
2.338.
Can you see my screen, Jenny?
Yeah.
Okay, so let me just pull up the.
8.
James, repeat what you got. I just want to make a note.
2.338. Oh, shoot.
Okay, yeah. Yeah, you would take the mean out of those 5 students. So that would be your X bar. And then
So
subtract
you-
it by the
I'm sorry, you're breaking up.
subtract it. Yeah. So you would take the mean out of those 5 numbers,
Okay.
and then you would subtract it with the mean that they give you, the 150.8 or whatever that number was, and then over 8.8, which is the standard deviation, right?
And then you
And
got to
then
do the,
over square root of 5. Yeah.
which is the sample mean. So I can show. Let me see. Do you want to see my calculator?
I want to see your screen. Yeah.
Okay, I have
Let
to.
me, let me stop sharing mine.
Okay, sorry, I have to do it on my Google calculator because I don't have my calculator with me. So here,
Yeah, I think
share.
set up right. I just haven't calculated it.
Okay, so can you see my screen?
Yes.
So do you see the 160? So 160 is the mean, right? So if you take those
Correct.
5 numbers and you find the mean, it's going to be 160.
Yep.
And then you subtract our mean, which is the 150.8.
Yep.
And then you're going to divide that by the standard deviation and the sample size, which is the 5.
Yes.
So
So our
sorry, when I make a mistake on my Google calculator, it takes me forever to get back to where I need to. So
Oh.
So the answer is 2.238.
No, 2.338.
yeah, 2.338.
Sorry, I clicked off of it to go back to the quiz, and I just couldn't remember. 2.338.
Yes.
Okay. All right, that makes sense.
Okay, I'll go with that.
Does it make sense? Does it
Yeah.
make sense to you?
Well,
Yeah.
I had it set up, but sometimes taking it, and I liked when you showed it to us because it showed where the parentheses are. So then that's how I know that I can put it in my calculator and get it right. So I actually wrote it down exactly like that so that I can calculate it on, I can set it up when I hand draw it on my piece of paper, but getting into the calculator right to get the right number.
Yeah.
And so that was helpful.
So Ed, the place you had it is we had to find the mean of those sample sizes, and once we found the mean of those sample sizes, we had to subtract it by the other mean.
Right.
okay.
Yeah. So
Right.
let me screen
and
share.
that was really my
Let
question.
me screen share. Yeah. Can you guys see my?
Jenny, we can't hear you.
I can't see your screen.
You can't.
Yes.
Oh, now I can. Yeah.
As long as
Okay.
you're talking, we see your screen.
You guys can just click
Okay.
on her name
Just
and
click on it; it'll bring it up.
It will stay up. Okay, got it.
Okay. Z-score formulas. Can you guys hear me?
Yep.
Yeah.
Yeah. Okay. So there are 2 Z-score formulas. So the one that we just did for that problem, we used this one. We used this one.
One of the things we talked about before
Yeah,
you
so-
came on is understanding which one we're trying to do. Because we get the first one, we even know the second one, we can write it down. But when they give you a problem, how can help us in our mind whether we're doing the first one or the second one?
Okay. So if they give you a sample size or n over here, then you're using this one because they don't give you information if you are not going to use it. So thing that you need to remember is that if they give you a sample size, then you would use the second one. And if they don't give you any sample size,
like that.
then you would use the first one.
Okay, sample size is second. They both start with an S. That's what I'm going to remember.
Oh, okay.
Yeah. Yeah.
Okay.
So have both of these formulas in your notes because you will need that for the exam.
Right. And I got that. I was thinking because I remember, and it probably was back in lesson 3 or something, where they were doing the ages of children, and they had to get this Z-score for each child. So then I was wondering if I needed to get the Z-score for each one of these 5 students individually, not collectively, and get the mean from them.
Oh, right.
I was confused.
Yeah,
Okay.
so if they give you a sample size, that's when you're getting the mean collectively. That's why in
Sample
the
size.
first Z-score formula, it's just an X because X means a value, right? And then the second formula, it's X bar, meaning sample size. I mean sample mean.
are.
And in order to get the sample mean, you need to have a sample size.
Okay.
I think I've got it.
Cool.
Yeah. No, that was good.
Good.
Okay.
I'm going an exam review tonight for your class.
Yeah.
I think I'm having it at 7:30 or something.
Yes, we talked
But
about
yeah,
that.
you guys should come if you can.
Yeah. Oh no, we'll be there.
Okay.
Yeah.
I'll be there.
Either with calculators ready.
All right. So let's go to question 9.
So for number 9, we'll take that z-score and we'll put it into the
Into
probability.
The
Yeah.
2.338. And which one are we looking for? We're looking for, what is the
It's gonna
probability?
be, it's gonna be greater. It's gonna be greater than our mean score for the.
Right.
So
Blue
it's
on the right.
0.0097.
Well, we're rounding to 4 decimal places. So yes, 0.0097.
Yep. Cool.
Okay. Now we're using the rest of from 10 to 14. Questions 10 to 14 are all using this.
Different information, yeah.
Suppose the mean GPA of BYU Idaho students is 3.5. I'm going to write that down. Mean 3.5. And the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81. Students will be drawn. Okay, what is the shape of the sampling distribution of the random variable sample x, which represents the sample mean of the 81 students who are selected?
That's approximately normal because it's a large number.
Yeah, 81's over 30, so we're going to go approximately normal.
Yep, even though it's left skewed.
Yep. Because they kept talking about, as long as anything's over 30, it's going to be approximately normal.
Right. Yeah. Or if it's or if the population is normally distributed.
Yeah. Yes.
So what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So that's just going to be
the mean is
the mean 3.5.
3.5. Yep.
Okay, that's what I've got. 3.5.
Yeah.
It's like I have written in my notes, the mean is the mean is the mean, which is exactly what Sister Lemon said.
That's what I said too. What's the standard deviation of the distribution of the sample means, the sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
So it's the standard deviation with a sample size.
Yes.
So it's going to, I'll wait.
No, I was listening.
Oh, well, I have the answer, but I don't want
he just wants to give the answer. Just give me a minute to see if I can get it.
Okay.
Of course, my calculator just died. So let me go back to. Okay.
So is this set up right? Is it 81 minus 3.5?
So let's, it's going to be.
No, the 81 comes down below. Never mind.
Okay. I always do
that. 3.5 minus 3.5? No, that can't be it. Hold on here. I'm messing up with the first number.
It's 3.5 divided by 0.7 to the square root of 81.
Don't you have to have two numbers at the top? X minus the mu over the standard deviation divided by the square root of n. And it's the first number x that I'm trying to figure out here.
Actually,
Are you guys in question number 13?
12.
we're on
12.
12. And I think the formula is asking for the standard deviation of the distribution sample. So I think that's the
Yeah.
one, the formula that starts with the sigma and then the x bar equals
Yeah, well,
top
that,
of a fraction sigma divided by the square root of n.
Yeah, that's your formula. Sigma over square root of n.
Okay.
No, over.
see,
Oh, so
the
0.07
sigma and the square and stuff throw me off. I need numbers.
That's the circle with the
No, I know
the
what
stairs
it looks
going
like.
up.
I just, that
Point-
kind of stuff makes my mind explode.
0.07 over the square root of 81.
Yeah.
Yep.
Okay.
All right, so I'm sorry. Walk me through that.
So when we're trying to find the standard deviation of the sample means, that's where you use the sigma over the square root of 81. Sorry, the sigma over the square root of n. So we take the standard deviation we were given, 0.7,
Right.
over,
No, but it's points. Yeah, 0.7.
yeah, 0.7 over the square root of n, which is 81, which is the sample size.
Yep.
Yeah.
So sigma or standard deviation over the square root of the sample size.
Okay.
Because I kind of write it out in words and also write it out in the symbol because it will help me.
Yeah.
You know.
The symbols make my head explode.
Yeah.
So 0.078.
Point. Oh yeah. Right.
So yeah, 0. So it's 0.0777777. So it's 0.778.
Mm-hmm.
Hey, that's what I've got.
0.77. Yeah, because it's 3, right? 3 decimals. Okay. Okay. 13.
Sorry,
Okay.
back notes.
Somebody else read this one.
So what's the probability that the mean GPA for?
You mean to read it out loud?
Yeah.
Yeah, sorry.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Well, this is using the applet, is it not?
Correct.
Yes. I think first we need to find this, and that's the
So we put negative, right?
We got to find the Z-score.
Yeah, we have to find the Z-score first.
So it's going to be the 3.3, and then we're going to subtract the mean, which is our 3.5, and then we're going to divide that by the standard deviation, which was 0.7, divided by the square root of the sample size, which is 81.
Right.
2.94.
I got negative 2.5714.
Okay, so it's 3.3 minus 3.5 equals 0.2. Add that by the points. I hate when you have to keep rolling back up to get the get the information again.
Yeah. There's not enough room on these screens.
Yeah.
Hey, James, what did you say your answer was?
0.005.
Okay, yeah. Yeah, that's correct.
7. Square root 3.1.
Okay, so then we can plop that in.
Okay. I don't have that though, so I'm sorry. Let's.
No, that's okay. Keep going. Yeah.
0.3 minus 3.5. You divide that by the 0.7. Divide that by the square root of 8. Is it 81? 81.
Yeah.
0.032.
Or I can show you my formula if it helps. I don't, maybe,
Yeah,
hopefully
no, it will. Yep.
hopefully my formula is right. Okay, let me grab that. So
Right.
So there's my formula right here.
0.3 minus.
And that's what I have also, by the way.
Yeah.
0.7.
Yes.
Oh, maybe that's what I'm doing wrong. 1. Nope. Stop it. 3 minus. Wait, so it's divided by 0.7, and then do you do divide it by the square root of 0.81, or just do the square root of 81?
I just put it as a square root of 81. I don't know if that's correct, but I always seem to get the right answer. So I don't know if I'm doing that correctly or not. I guess I can try it the other way and see if I get the same answer.
Well, I have the same answer. What I've been doing is on the denominator, I've been putting the parentheses on both sides.
Oh, okay.
So the order of operations will take the numerator parentheses and then the denominator parentheses, make those whole numbers or whatever numbers.
Yeah.
And then calculate from there. So I think it works out the same.
All right, got it. I don't know what I was doing wrong, because I feel like I was doing the same thing the whole time, but.
Yeah.
And so then we take that and then we put that in the probability.
In the applet.
Right.
Yeah.
And it wants
It's a negative.
less than the 3.3. So we put the 3.3 in. I mean, we put the z-score in at 0.005, but we want it to the left.
Yep.
And so it's 0.498.
Yeah, I got 0.0051. I don't,
On the applet?
Yeah.
I did too.
Okay. I wonder if I have a little bit, you know what? I think I had a little bit in my middle. Maybe not. Let me look at
All
that.
right. So we had negative 2.57.
2.571.
Right, 2.571. And you put that in the applet?
Yep.
Oh,
For you.
okay. I got confused by you. 0.0051.
Yep.
Oof.
0.051.
Cool. And then, are we good there?
That
So-
was 14, right?
Yeah, Raylene,
That was-
So it's 0.004.
No.
005.
Okay. All right. Did I get ahead of myself? Hold on.
Yeah, that was number 13. I think you were ahead of us.
Oh, okay. So let me make sure. So hold on. 12
Go
I have
back to
0.778.
Yep.
And then 13, I put in the z-score of 0.0051, right?
No,
No.
the z-score is 2.571.
Yeah.
Okay. And that's what I put in.
Right.
0.57. Greater, no, is it the less than the greater? Now I'm all messed up because I got less than.
It's going to be less than, yep.
And so both the middle, both
No,
the,
just to the left of the red line. That little tiny
Got-
piece.
right. Oh, okay. So I did get it. 0.0051 is the next one. Okay. All right.
Cool. And then what is the probability that the mean GPA for 81 randomly selected BYU students will be greater? So now we got to go the other way of the 3.3. So we just highlight the other things that are above or that were on the other side of that 0.005, right? So then it'd be 0.995.
Yes, that's what I've got.
Okay. Makes sense?
Yep.
Yeah, I just need to see how what's the probability that the GPA for will be greater than the 3.3. Okay. Because we, so you had to highlight like the middle and the right side.
Yep.
Because the 3.3 is over. Okay, got it. So we're doing 0.995.
Yes. Okay, this looks like a fun story problem. Okay, so I'll read it. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights, write this down, is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours is in the positive direction.
All right. So who wants to take the lead? Or do we all want to do it separately and then come to an idea of what our answer is?
I'd like to talk it through.
Okay.
First off, what's the formula we're going to use to set it up? We're going to use.
Go ahead.
Go ahead.
So we got.
Sample.
So what's the question, right? It asks us what the probability is, right?
Right.
So we know we need to find the z-score.
Right.
Plug it into the applet to get the probability.
Right.
Yep. And so we know we have a bunch of different numbers, right? We have the 185, which is going to be our mean. We have our 177.6,
which is our sample population.
It's going to be our data point, I think, or
Sample mean.
Sample mean, yeah. And then our 26.7 is our standard deviation, and then our sample size is going to be 48.
So I have 177.6 minus 185 divided by 26.7 over the square root of 48.
Yep.
Yep.
Okay. So now it's plugging it in the calculators, right? 7.6 minus 185 divided by 26.7 over the square root of 48.
$1.92.
Yep.
Whoa. And you could tell that was not very confident, was it?
No, that's what I got. I guess I shouldn't assume it's right.
That's what I got.
Yep. Me too.
Okay.
So now we need to go ahead and plug that number. That's our z-score. So we plug that in. And so I think this is the important part. It says as extreme or more extreme means that we are not only interested in the values that are lower than the ones that are observed, but also the values that are far away. So what I think is we got to find both spectrums we have to highlight both spectrums of the mean, or of the applet.
Both tails, the left and the right.
Yep, that's correct.
And we're putting in 1.920.
Right.
Yep.
So it's 0.0549 or
Yeah, let's see how
0.055.
Around it.
Yep, so rounding it would be 0.
Places, so 0.055.
Yeah.
Yep.
Yeah, that's correct.
Yep.
All right.
Have you won the watch I gave you? Have you won that watch I got you for Christmas?
Sweet.
Raylene, do you want to go over the answers? Because we were about one answer off. Do you want to review real quick?
Yeah. Yeah, let's do that.
Okay. So 3 is 0.175.
I'm scrolling up. I'm scrolling up. Give me just a sec. Okay, there we go. Yes.
Okay, so 3.175. 4 is the second one, the distribution of the samples.
Yes.
5 is the last one, the law of large numbers.
Yes.
6 is 1.045.
Yes.
7 is 0.148.
Yep.
8 is 2.338. Are you with us, Raylene?
Yep, I'm here. I'm here. Yeah. Sorry.
9 is 0.0097. 10 is the third one, approximately normal. 11 is 3.5. 12 is 0.078.
Now I had
No.
0.778.
0.778.
Which one?
0.778 for 12.
Okay, good. I'm glad we went over this. That particular question asks us to round to 3 decimal places.
Yeah, so 0.78.
And you wrote down 4 places.
No, I have
No,
0.778.
0.778.
Yeah, I put 0.778.
Yeah, but you got to round to 3 decimal places.
I did 0.778.
No, there has to be. It's 0.078.
Oh, okay, that's where I meant. Okay. Okay. So if I point from the decimal, it's 0.0. So I've got an extra 7 in here.
Yeah.
Okay.
And this is the question that we got crossed up on too. So
Yeah.
that makes sense.
All right.
Okay, so 12 is 0.078.
Yes.
Question 13 is 0.005.
Yes.
Question 14 is 0.995. And question 15 is 0.055.
Yes.
Yep.
Okay, we're on the same
Cool.
page.
Yep.
I think it's pretty cool. Am I gonna be nesting car?
There we go.
Yeah, that was all of them. They were all correct, thank goodness.
So you guys, next time when you are taking your exam or your quiz, just remember that if they give you a sample size, then you would use the other formula. And also be careful when you input your numbers into the z-score formula. If possible, you guys should take a picture of how you're doing it right now, so that way you're always putting it right in the right order.
Okay.
That makes sense.
Yeah, because you don't want to trip up on it and you know the answer and you know how to do it. It just
Right.
happened that you, yeah.
Got it. Hey, do you know how many questions are on exam number 1?
What was that?
Do you know how many questions are on exam number 1? Is it
I can check right now.
like 80
Hey,
or 90?
Jason, do you have? I don't think it's that much.
Yeah, I didn't know if it's like 10, 20, 50.
Let me check. But I will talk about what will be on the exam. I won't tell you what questions exactly, but I will be.
No, the number of questions. Like, is there 20 or 25 or 30?
I think
Yeah, I'm checking that right now. Hold on. Where is it? Oh, there. Okay, there are 38 questions.
38 questions.
Oh, wow. Okay.
So there's an announcement that was made today that I'm not sure who it was by, but it shows the 38 questions and it shows all the different things that we should probably know.
Okay.
We have 4 hours to complete it. That's nice.
Oh, wow. What's the due date?
Wednesday?
Yeah, Wednesday. That sounds familiar.
Okay.
Oh, she already did everything. Okay.
Yeah, it closes at 11 p.m. on Wednesday.
But she says not to wait till then.
Right. Oh,
Cool.
Okay,
All
if you
right,
guys
I
don't
gotta
have any questions, I'm gonna go.
All right, thank you.
you.
Thank you.
But
Yeah, no problem.
7:30. Thanks, Jenny.
Okay, see you guys. Yeah, you're welcome. Bye.
Okay, so that's Wednesday the 7th, right?
That's, yeah, I think it opens on Monday
Okay.
or either Saturday or Monday. I don't know the, I was going to look to see if I could see the announcement she posted. I mean, she's really so good about posting stuff.
Yeah. I chose this class specifically because everybody said that Sister Lemon was fabulous, and she is.
I just lucked out then. There are 38 questions. It's timed. It opens Monday the 5th at 11 p.m.
Okay.
Really Tuesday for
It's
me.
basically Tuesday.
Because if that's 11 p.m. Mountain Time,
Yeah, that's 1
that's 1
a.m.
a.m. here. I'm not going to start a 4-hour test at 1 a.m.
Yeah, me either.
Closes Wednesday at 11 p.m. So really, it's you have all day Tuesday. You should plan on doing it Tuesday, which Tuesday's such a bad day for me at work.
Now, are we having group meeting on Tuesday as well?
Oh my gosh, probably, right?
Yeah.
Good heavens. Class is very late, like time intensive.
Yeah.
So
Well,
we could use that time to kind of study and rehearse with each other, making sure we have everything straight in our heads unless we've already taken the test. I mean,
Yeah.
Jim, you'll have the test taken by then, right?
He's gone.
Oh,
Yeah, well, but he, if he takes the test, then we don't want to really talk about it because we don't want to talk about it if he's already taken it.
right. If he's already taken it, then we can't really talk about it. He'll have to be silent.
That's true.
Because it wouldn't be fair to him or us,
We don't have.
Yeah, there's still a group meeting quiz due for lesson 8.
Oh,
Holy moly.
it's going to be a busy week.
I wished it was open on Saturday,
I know.
Yeah.
so you could take it Monday or whatever. So
Monday would be best because Tuesday and Wednesday I'm slammed at work, but
Yeah.
I'm gonna have to figure it out.
yeah. So Saturday will be good study time, and I guess Monday really good study time, so that by the time I can get to the exam, I feel like I've gotten it. Like I really am. I'm going to create flashcards.
Yeah.
It's a good idea.
So, all right,
With-
I gotta
with-
go.
Okay, thank
Okay.
you.
Thank you.
Bye. See you guys.
Bye bye.